Good afternoon, students, and welcome to the Q&A summer course. Students, I'll quickly introduce myself. So, students, I'm Sunit Kumar. I am your mathematics teacher, and so today I'll continue with number system, which we had started, last week. So, in today's class, what we are going to do is we are going to, so last class what we did was we plotted all these irrational numbers on the number line. So today we'll talk about decimal representation of rational and irrational numbers both. Okay. So let us start the session, students. Good afternoon. Good afternoon, Rudra Pratap Singh. So Rudra, can you also tell me your, school name? So when you join these classes, you should join with your name, the name of the school, and the grade. So that will help me understand from which school you are. So let's start the class, students. So as I said, we'll do this chapter number system today in the class. And the prerequisite for today's class is that you should know about the number system. That is natural numbers, whole numbers, rational numbers, irrational numbers, and real numbers. So specifically, you should know about rational numbers and irrational numbers and the properties of rational and irrational numbers. In today's class, as I discussed, we'll discuss about real numbers and their decimal expansion. Okay. So decimal expansion of rational numbers. So there are two types of decimal expansion of rational numbers, right? So when you convert a rational number, so rational number is of the form p by q, right? So these are the ratio of integers p by q, right? Where p and q belongs to integers, belongs to z, and q is not equal to 0, right? These are the conditions for a ratio to become a rational number. So it should be a ratio of integers and the denominator should not be equal to 0. Now, when you convert this, fraction or rational number in decimal form, so in decimal form, there are two forms possible for a rational number. So decimal form of rational number. So it will be either terminating, right? Or it will be non-terminating and recurring. Recurring or repeating is one thing only. Is it clear? Now, terminating decimal example, you can have 1.5. This is a terminating decimal because after 0.5, it stops. Similarly, non-terminating and recurring, you can have an example 1.3333 and so on. Right? Is it clear? So this can also be written as 1.3 and a bar over that, which tells you that this digit after decimal is being repeated. So this is a representation basically. Okay. So there are two ways in which you can convert a rational number into decimal form. There are two possible ways. So two possible forms. One is terminating decimal and other is non-terminating and recurring decimals. Is this clear, students? Have you understood this? Anna and Kavin and Rudra. Have you guys understood it? Yeah, great. So now, so decimal expansion of a rational number is either terminating or non-terminating, recurring or repeating. So recurring also means repeating. It's one and the same thing. When the digit repeats, it is called to reoccur. So recurring, right? Now a number whose decimal expansion is terminating or non-terminating and recurring is rational. So all such numbers whose decimal representation is either terminating decimal or non-terminating and recurring decimal, all of these are rational numbers. Both these are rational numbers. Okay. If you quickly want to write this down, so, it is a good practice to make a note of whatever is important in the class. So you should always sit with a notebook and pen and paper, basically, so that you can note down whatever is important in your notebook. And after the summer course is over, when you go back to school, when the school reopens, you will be able to revise all the concepts properly. Is it clear? Shall we go ahead? Okay. Now decimal expansion of irrational numbers. So when you convert an irrational number into decimal form, right? So it will be, the decimal form would be non-terminating and non-repeating, or non-terminating and non-recurring. Okay. So decimal expansion of irrational number is non-terminating and non-recurring, means it will not terminate and it will neither repeat. For example, if you have a number like this, 1.01, 2 times 0, 1, 3 times 0 and then 1, 4 times 0 and then 1, and keeps on repeating. Keeps on, it does not terminate. It goes on. So here you can see that this is not terminating, but it is not repeating also. Here you had 1 0, here you had 2 0, then 3 0, then 4 0. So because the digits are not repeating, right, continuously, that's why we say that it is non-terminating and non-repeating, or non-terminating or non-recurring. Is this clear? So any such decimal of the form non-terminating and non-recurring is irrational. So a number whose decimal expansion is non-terminating and non-recurring is irrational number, right? So we have seen that all square root of prime numbers, root 2, root 3, these are all irrational number. Pi is an irrational number. And another form of irrational number is this, where you write a decimal into non-terminating and non-repeating, or non-terminating and non-recurring decimal. Those are also irrational numbers. Is it clear? Have you understood the concept, students? You can unmute yourself and tell me when I ask you. Okay. Now, quickly, students, the first question is find the decimal expansion of 10 by 3, 7 by 8, and 1 by 7. So we'll do it one by one and write the decimal expansion, right? So 10 by 3. So 10 by 3, what we'll do, we'll divide 10 over 3. So 3 times 3 is 9. You have 1 as remainder. So when you put a decimal point here, you will get a 0 here. So again, 3 times is 9. Because there is a decimal, you will always get 1 0 in the next steps. So this will keep on continuing, right? And this will keep on continuing. So the digit in the quotient also keeps on repeating. So 10 by 3 can be written as 3.333 and so on, which can be written as 3.3 and then bar, which tells that your digit 3 after decimal is repeating. Clear? Is it clear, students? Now let us find the decimal expansion of 7 by 8. So to find the decimal expansion of 7 by 8, what we'll do, we'll quickly rub this and we will divide 7 by 8. So 7 when divided by 8, right? So because 7 is less than 8, right? It is a proper fraction. So what we'll do, we'll put a decimal point at the start. You will have 70 here. So we know that 8 times 64. We'll subtract it, we'll have 6. And because there is a decimal 60, so then we have 8 7 times is 56. If you subtract, you will get 4. 40. 8 times 5 is 40. So the remainder is 0. When the remainder becomes 0, that means this is a terminating decimal. So what kind of decimal was this? This was non-terminating and recurring. Now for 7 by 8, because you are getting a remainder as 0, so this will be terminating. So this is 0.875. So this is a terminating decimal. Clear? Till this point, is it clear? So we have got 10 by 3 converted into decimal, 7 by 8 converted into decimal. Because these are rational numbers, it will have two forms of decimal. One is either it will be terminating or it will be non-terminating and recurring. So we have seen one examples of each here. Clear, students? Okay, I'll quickly rub this. Now we have 1 by 7. So when you divide 1 by 7, so you have, because again this is a proper fraction, so you will put a point decimal there. So you will have 10. So 7 times 1 is 7. You will have remainder as 3, 30. 7 4 times is 28. Remainder is 2, 20. 7 times 2 is 14. So you have 6. 7 times 8 is 56. 40. 7 times 5 is 35. You have 50. 7 times 7 is 49. Now you have got 1. So once you have got 1, so that means, you will put 0 here. So this is same as this number, right? This is same as this number. So now after this whole process is going to repeat, right? Will it repeat or not? It will repeat, right? Because after 10 again you will get remainder as 3 and that will keep on happening. So this step is going to repeat continuously. So that means this will keep on going. So this is what is repeating basically. So this is non-terminating and recurring again. So 1 by 7 is 0.142857. These digits are repeating. So this is non-terminating and recurring. One more important thing which you need to note here is the repetition of the remainder. So the quotient repeats and the remainder also repeats. So the remainder repeats. Initially the remainder was 3, then you had 2, then you had 6, 4, 5, and then 1. So this keeps on repeating. Is it clear? Is this clear, students? Everyone is clear till this point? Because this is very important. You need to understand, especially the 1 by 7 thing, because there is a question in NCERT as well around this, where you have to calculate 2 by 7, 3 by 7, 4 by 7. You have to convert them into decimal expansion. So we will be using this concepts of repetition of remainder as well as quotient when we are getting the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, and 6 by 7. Okay. Rudra, do you want to ask some question? Or you have understood it? Because you are writing 2 times y, so I thought that if there is a question there. So you can note down this. I have just moved aside so that you can write it. Give me a thumbs up once you have written it. Kavin, Hana, and Rudra. You have understood the concept, Subransu. Okay. So students, I'll move to the next part now. Now, the next question is, show that 3.142678 is a rational number. In other words, express 3.142678 in the form P by Q, where P and Q are integers and Q is not equal to 0. So when you convert a decimal into rational number, so 3.142678, if you have to convert it into rational, there are how many digits after decimal? There are 6 digits after decimal. So you will have to divide it by 10 to the power 6. So this is 3142678 divided by 1 followed by 6 zeros. Okay. So this is your P by Q form. So to convert a terminating decimal to P by Q form, you have to just divide that decimal number. You have to remove the decimal and then divide that decimal by the number of digits by counting the number of digits after decimal and replacing it by zeros in the denominator. So 1 and then followed by those many zeros. Is this clear? Students, is it clear? You have understood this? Okay. Let's move ahead, students. Now the next question is, show that 0.3333, that is 0.3 bar, so 3 is repeating, can be expressed in the form P by Q. Because this is, what form is this? This is non-terminating and repeating, right? This is non-terminating and repeating decimal. So for every non-terminating and repeating decimal, that can be converted in the form P by Q, right? So we have to show how to do this. So we have, so in these questions, what we do, we write it as let x is equal to, so let x is equal to 0.3333 plus, that means we can write it as 0.3 bar. Now what we do is, next we multiply both LHS and RHS by 10, right? So because there is only one digit which is repeating, we are multiplying it by 10. So our idea is to move to our decimal point after one repetition. So after one repetition, if I have to move my decimal point here, I'll multiply by 10. So multiplying both LHS and RHS. So multiplying both LHS and RHS by 10, we get 10x is equal to 3.333 and so on, which is equal to 3.3 bar. So this is your equation number 1 and this is your equation number 2. What we'll do, students, is we'll subtract first from 2. So subtracting equation 1 from 2, we get, so we'll get 10x minus x is equal to 3.3 bar minus 0.3 bar. So this will be equal to, because number after decimal is same, so we are going to subtract 3, 0.3 bar gets cancelled. So you have 3 here. 10x minus x is 9x, which is equal to 3. So that means x will be equal to 3 over 9, which is 1 by 3. So the decimal expansion of 0.3 bar, the P by Q form of 0.3 bar is 1 by 3. Is this clear, students? Students, is this clear? Have you understood this concept? Okay. So Subhranshu, Kamalan, Saktivel, Hana and Samagra. Samagna. Okay. Let's go to the next. Now, similar question, but the difference here is that there are two digits which are repeating. So show that 1.272727. So you can see that these two digits are repeating here, right? So you have a bar over 27. So this is again non-terminating and repeating decimal, right? So to solve these questions, as we saw, we start with this step. Let x is equal to 1.272727 and so on, which is equal to 1.27 and bar over that. Now, as I said in the previous question, your second step is to move this decimal point after one repetition. So because 27 is repeating, we'll move this decimal 2 digits towards right. To move the decimal 2 digits towards right, you will have to multiply it by 100. So multiplying both sides of equation by 100, we get, so you will have 100x is 127.27 bar, or you can write it 272727 repeating, that is 127.27 bar. So this is your equation number 1 here, and this is your equation number 2. Okay. So now subtracting 1 from 2, we get. So you are subtracting 1 from 2. So LHS will be 100x minus x and RHS will be 127.27 bar minus 1.27 bar. So this is 0.27 bar gets cancelled, right? You have 127 minus 1, which is 126. So this is 99x is equal to 126. This means x is equal to 126 over 99. So the P by Q form here is 126 by 99. Is this clear? So first example was where only one digit was repeating. The second example, there are two digits which are repeating, and that's why we are multiplying it by 100. Is it clear to everyone? Students, you have understood this, right? Why we are multiplying it by 100? I hope this is clear to everyone. Okay, great. So I hope you have noted this down. Please note this down quickly and then we can move to the next. Okay. Let's move to the next question, students. Now show that 0. Yeah, Kavin, you're saying something? Okay. So here in this question, students, you have 0.2, 35, 35, 35 and so on. So only these two digits are repeating, 3 and 5. And that's why you can find this bar only over 3, 5 and not over 2. 2 is not repeating. So this is also another example of non-terminating and repeating. So non-terminating and recurring decimal, right? Now here the approach is a bit different. Initially what we saw was we were moving our decimal from to the point where the repetition, one round of repetition has been completed. So here what first we'll do, we'll move decimal to this point from where repetition starts, and then we'll move to this point where one repetition has been completed. 3 5 is repeating, right? So one calculation will bring my decimal to the place from where repetition is starting, and other calculation will give me take the decimal to a place where first repetition has been completed and second is started. So again, let x is equal to 0.2353535 and so on, which is 0.235 and then bar over this. Now, as I said, we have to move the decimal first to the place where the repetition is starting. So multiplying by 10, so this is your first equation. So multiplying by 10 on both sides, we are going to get 10x is equal to 2.353535 and so on. That is 2.35 and bar over that. Second equation. Okay. Now, multiplying second equation. Now what is our second step? We have to move the decimal to a place where first repetition has been completed. Means we have to move it here now. 2 decimal place to the right. So multiplying this equation 2 by 100, because 2 decimal places, 2 digits are repeating, right? So we'll multiply it by 100. We get, see, 10x if you multiply by 100, it will become 1000x is equal to 235.353535 and so on, which is 235.35 and then bar over that. So this is your third equation. Is this clear till here? Now, subtracting 2 from the equation 3. So when you subtract 2 from 3, you will have 1000x minus of 10x is 235.35 bar minus of 2.35 bar. So what will this give? I'll write it here. So 1000x minus 10x is 990x is equal to 235 minus 2 will give you 233 and 0.35 bar that gets cancelled. So this is 233. So x is equal to 233 divided by 990. Is it clear? So this is your P by Q form of this decimal. Is this clear to everyone? Has everyone understood this? Students, have you understood this? Okay. Now these methods, you can see that this is a longer method, right? We have to write everything. So in exam, you will do in the same way. But because this is a foundation class, we'll not limit ourselves here. We'll go a step forward. So I'll give you a method to where you can write the answers in one step. But in exam, you will have to show all the steps. That is just for your knowledge, where if you get a MCQ kind of question, or in Olympiads, or in further classes, competitive exams where you appear in these exams, you can use these shortcuts to calculate directly. Okay. So I'll take the same examples and then we'll showcase that shortcut to you. So has everyone written this? Please write this down, and then we can go to a shortcut. Has everyone written this down? Okay. Let's move to the next. Now, students, what I'll tell you now is the shortcut method. So how to write the P by Q form from non-terminating and recurring decimals without solving. So right now we had assumed it, let x is equal to something. Then we multiplied by 10 or 100 in different cases, right? And then we got the answer. It is a tedious method, right? Now I'll tell you a method. Please listen to it carefully. I'll repeat it, right? But please listen to it carefully. Try and understand it in the first go only. So I'll take one example first, the last one first, and then I'll come back here, right? So how to write the P by Q form from non-terminating and recurring decimal without solving? For example, we have this number 0.235 and then 35 is repeating. Okay. So what we are going to do, students, first, we will, whatever the number is, this is the number, right? If you remove all decimal and everything, all the bars and everything, write that number as it is. So as it is, the number is 235. If I remove decimal and bar and everything, the number is 235. First step is write the number without the decimal and the bar. So I'll write the steps as well later on. So once you have written that number, subtract that number from it, which is not repeating. So which number is not repeating? 2 is not repeating, right? There is only one number which is not, one digit which is not repeating, 2. So I will subtract that from this, the number which is not repeating, divided by number of nines. Okay, number of nines as the number of digits repeating. There are 2 digits which are repeating, 3 and 5. So number of nines is 2 nines, 9 and 9. Followed by number of zeros which are not repeating and are after the decimal. So after decimal only there is one digit which is not repeating, right? So that's why we will follow it by 1 0. Okay. So I'll tell you one by one. So this is number as it is 235 subtracted by all those digits which are, so number which is not repeating, divided by number of nines as the number of digits which are repeating, followed by number of zeros for number of digits which are not repeating and after the decimal. So this will be equal to directly 233 by 990. Is it clear? Is this method clear? I'll give you one more example. Here in 1.27 bar. So 1.27 bar, we will write the number directly as 127. Subtract that number which is not repeating. So 1 is not repeating. So I'll write 127 minus 1 divided by number of nines as the number of digits which are repeating, 99, and followed by 0 if there is some digit after decimal which is not repeating, so here we don't have any digit after decimal which is not repeating. So only 99 will be there. There will be no 0. So 127 minus 1 is 126 divided by 99. Clear? For 0.3 bar, this is, I'll write the number as it is minus the digits which are not repeating. There is no digit which is not repeating. There is only one non-zero digit, right? So the digit which is not repeating is 0. So 3 minus 0 divided by number of nines as the number of digits repeating. There is only one digit which is repeating, so there will be 1 9. So this is equal to 3 by 9, which is equal to 1 by 3. Did you get the answer in one go? Now, I have taken time because I have explained it to you. But if you don't want to be, means if you do it on your own, it will take a lesser time. So this is a new thing which you learned, right? Other things you may be knowing because that is something which is there in the syllabus. But this is a very powerful method. So please take a note of this. Okay? You will not find these in many books or anything. I'll take few more examples if you've done this. Are you done with this? Have you written this? Okay. So I'll quickly take few more examples. So students, let's take one more, very complicated example. 2.34678, 678, 678, and so on. So this can be written as 2.34 and then 678 bar over that. So this can directly be, if I write this number as it is, so this will be 234678. Minus of digits which are not repeating, so that is 234, divided by number of nines which are repeating. So there are 3 digits which are repeating, so 3 9, and followed by as many zeros after decimal which are not repeating. So there are 2 digits after decimal which are not repeating. So there will be 2 0. So I can directly write it as 8 minus 4 is 4, 7 minus 3 is 4, 6 minus 2 is 4, and then 2 3 4. So 2 3 4 444 divided by 999 00. Is this clear? Students, is it clear? Is this method very interesting and something which you would always remember? Okay, good. Thank you. Please note this down, students. I hope everyone has noted it down. Okay. So now students, I'll quickly take you to the platform and will tell you today's homework. So students, when you log in on the platform, so students who don't have a login ID and password, first you need to write your name in the chat box so that we can create your login ID and password. We'll have our next round of diagnostic test on Friday, 11:30 a.m. So Friday at 11:30 a.m., those students who have not taken the diagnostic test can take the test so that the platform calibrates itself. When you go and practice there, you will get questions of your level. Okay, so platform practice is very important to understand your topic level proficiency. So whatever we have taught in the class, you can check what is your level of understanding there in that topic. So for that, students, what you will do, you will go to the practice session assessment. practice, custom practice. Go to the chapter which we are doing right now, that is number system. And in number system, as I've given already two homeworks. So today what you will do, you will explain rationality by representing numbers in P by Q form. This second one, the second topic is your homework. So go back and practice on the platform. How many students practiced it today in the yesterday when I gave them homework? Did anyone practice? Okay, Hannah has done it. Anyone else? So students, most of you, I think you have your login ID and password. Does everyone have a login ID and password, student? If you don't have a login ID and password, please write your name in the chat box. We'll give you a call, create that login ID and password so that you can take the test on Friday and start your practice as soon as possible. Okay, Rudra and Kamalan, we'll try to connect with you and we'll create your ID and password so that you can go and practice on the platform and do your homeworks when I have completed it. Okay? So thank you, students. We thank you for joining in. Bye and take care. Have a very nice day. Keep on practicing on the platform and keep on improving yourselves every day. Bye. Thank you.